So first of all, thank you very much, like Rob said, for everyone who came here today in typical Cape Townian weather. It sucks outside, and I know that often people don't like to leave. I certainly don't like to leave when it's crappy weather outside, so thanks very much for coming. Tonight, in the context of scaling tech teams, I just want to talk very briefly about embracing technical debt. It's quite a big topic. I don't have a lot of time. I don't want to keep you all here and bore you with a whole bunch of details, but I do think it's a very interesting conversation to have, because technical debt is something that everyone faces. Anyone, like from the moment you write your first line of code, you've probably got some kind of technical debt. So I want to talk a little bit about that, because I think that if you embrace that, and if you come to terms with what technical debt is for you and your organization, then you're going to have at least one stepping stone in the direction of scaling your company and your organization and your engineering efforts. So as Rob said, my name's Sven. That's me with COVID hair. Actually, it's the only way I could lose weight was to shave my beard. But as Rob said, I've been around in the DevOps game and in the software industry for 18 years or so. And back when I started, it wasn't called DevOps, it was called something else. And I've always been kind of interested in the intersection of like software and broader systems and infrastructure in particular. So some of the things I talk about this evening are going to be presented from that perspective, but generally speaking, I'm going to try and cover technical debt from a sort of a baseline principle perspective, and hopefully you'll find something useful and relevant and that you can take away and implement for yourselves, or at least begin a conversation about. So I'm going to go through a very, very quick history lesson just to give you a little bit of a background of where Peach has come from and what we're talking about when we say technical debt. Then I'm going to level set and talk a little bit about what I think technical debt actually is, and try and give you a working definition that is both easy to comprehend and is also useful to you in terms of how it allows you to reason about things. Then I'll quickly blast through an example. This isn't going to be a technical presentation by any stretch of the imagination. I just want to give you one simple example from our ecosystem, from Peach's engineering efforts, that will give you kind of an idea of how we've been thinking about this stuff. And then I'll wrap up with some final thoughts. In the beginning, things were really simple. Peach, like everything starts out really simple. Peach started, 2012. It's been going around for a reasonable amount of time, but when it started, there was a single web application. It was like a simple thing. It had a front end and it had a back end, and it was a simple system, and everyone could understand it very easily. And over time, it grew, and it grew, and it grew, and it grew. And it got complicated. It got complicated both in terms of the things that were implemented, but it also got complicated in terms of like how we thought about it and what we thought it could be and what we thought we could do with the organization and where we wanted to be and what features we wanted to use, implement, and what we thought our customers needed, and everything got more complicated. And that's just like a fact of life, right? That's how software engineering goes. Anyone who's spent any time in this industry knows that like things get complicated. The moment you start writing code, the moment you start releasing features, like no plan survives first contact with the enemy. No software survives first deployment into production. Like that's just the way things are. We went from a simple like web stack implementation of our first application, which we still actually have customers that use to this day, which is like a really amazing thing when you actually think about it. We went from that first initial implementation to now we've got sort of 500, 600, 700 Lambda functions running in production. We have a bunch of database backends. We have a bunch of data storage backends, not just like relational databases. We've got some NoSQL databases, and we've got some caching, and we've got some, API gateways, and we've got hooks, and we've got triggers, and we've got queues, and we've got messaging, and it just like it gets bigger and bigger and bigger. And you can just see how the sprawl kind of happens over time. And this sprawl is important because that's the stuff that we're dealing with all the time. It's not just like that it's there, but it's also that you have to then expand your thinking about it. You have to remember that, there's this Amazon bucket that does a thing, or, oh, there's this particular way that we implemented this thing in this environment or in this account, or this feature isn't quite the same as all the other features because we used a different version of the programming language, and it's that thinking that is the real problem. It's the real kind of grit in the works. So one of the things that I think is really important when it comes to dealing with technical debt is standards. And you can see here, these are, I pulled this picture off the net. It's like, they're all rulers. They're all measuring something. They're probably measuring inches or centimeters, but they're all slightly different. And that's part of the problem. When you join an engineering team, if it's just you have your way of thinking about a thing and you have your way of doing a thing. Then someone else comes along and they have a slightly different way of doing things. Maybe they've got their editor set up slightly differently, or maybe they're using a slightly different framework for testing. Maybe they're using a slightly different language. And this is the problem, right? Peach faces this problem right now. Since since 2020, we've probably had, 3-4 different languages at any one time rocking around in our production environment. We've got a bunch of different web frameworks. We've got a bunch of different testing frameworks. We've got a bunch of different language frameworks. We've got a whole variety of different stuff, and we've got different teams working on different areas of our organization, trying to implement things the best way that they can, with the goal of doing the very best that they can for their customers, but they've got to interact with each other and they've got to interact with this bigger system as a whole. And it's really, really, really hard to do. And what do we do about it is the question. So yeah, you can just imagine the frustration, right? This is fine. It's not just frustrating for us as engineers, it's frustrating for us as product people, it's frustrating for us as business owners, it's frustrating for our investors, it's frustrating for our customers. It's risky. There are security issues that come with this sprawl. There are outages that come with this sprawl. There are misunderstandings. And we're very, very privileged to be working in the financial services industry. I think it's an incredibly interesting space to be working in. But at the end of the day, we're dealing with people's money, right? If somebody doesn't get paid, maybe that's just a bad day for me at the office. But for somebody else, that's I don't get to pay my staff. I don't get to buy my kids school shoes. That sounds potentially overly dramatic, but I think the point is well worth making, that we're dealing with people's money. It's a very serious thing, and we need to look after it, and we need to do the best we can with it. So it's not okay to be in a situation where everything's on fire and you're going well, this is fine. Tech debt is a real problem. We need to address it. So I just want to quickly level set and talk about what tech debt is. It's a term that I've used a couple of times now in the presentation. It's a term that I'm sure a lot of you are familiar with in some shape, way, or form. But I just want to talk about what I think it is and a little bit about where it came from. So this quote is attributed to a software engineer, a very well-known software engineer, a guy called Ward Cunningham. He's kind of one of the godfathers of software engineering, certainly in a sort of a corporate or industrial kind of context. He says, if we fail to make our program align with what we then understood to be the proper way to think about our financial objects, then we were going to continually stumble over that disagreement, and that would slow us down, which is like paying interest on a loan. So he was working for a financial institution at the time, and he was trying to think of a way to explain to his colleagues what it was like when you had to keep thinking about something in order to re-understand it again and again and again. Because that's the problem with complex implementations and complex solutions. You have to keep thinking about it. There's this cognitive overhead that happens. What I think about technical debt, and the way I like to think about technical debt, is that it is that cognitive overhead. Anything that is different from the way you think it ought to be, and what you agree with your coworkers and within your organization, whatever your internal culture thinks a thing ought to be, anything that is different from the way it ought to be is technical debt. That gap is the technical debt. And the reason I say that is because if you are working in a software organization that agrees that it's okay for you to deploy code into production from your laptop, then not having a code pipeline is not technical debt. Just because some textbook says that you should have pipelines doesn't mean you have to have them. It's about what works for your organization, it's about what works for your product, and it's about what your internal agreements are about the way things should be. So if you agree that, what's the classic argument? It's like Vim versus Emacs and tabs versus spaces. If you agree that it doesn't matter whether you use tabs or spaces, then like having tabs or spaces in your code is not technical debt, and it's not something that you should be worrying about, because if you are, then you're not focusing on the actual technical debt, which is the things that are not the way you think they should be or ought to be. And that ought to be is a conversation that you have to have. And if you aren't having it ongoingly, you need to start today. You need to start having that conversation with your coworkers and your colleagues. Like, what do we say is the line in the sand about how things ought to be? What are the standards? What are the conventions? What are the internal values and rules that we have for our product, for our design, for everything that we will hold ourselves to? Because anything that isn't that, that's the place you start tackling. Like, that's the first thing you've got to start dealing with. And you've got to have that conversation, because if you don't, then you've got Rob, who thinks that we should actually be fine to deploy from our laptops into production. Sven, who's like, that's insane. I refuse to work in an environment where we don't have an automated pipeline running on some workload runner somewhere. And someone else who thinks it's okay to use multiple different cloud platforms, and someone else who thinks, no, Google Cloud Platform is the one true platform. If you have that kind of disagreement internally, then anytime you meet with a team member, or you meet with another team, or you meet with a product person, or you meet with a manager, or you meet with, whatever, a customer even, and you have a conversation about something, they've got a model in their head, and you've got a different model in your head, and that becomes hard to talk about. And that's where the friction really is, and that's the stuff that really slows us down. Typing's relatively easy, right? We can all type, it's straightforward, that's not hard. It's actually understanding and thinking about what it is that you're implementing. That's the hard stuff. And that's the bit that's technical debt from my perspective, and that's the thing that slows down and makes scaling teams very, very difficult. So I want to quickly whiz through a single example that I think is relatively straightforward to talk a little bit about how we've started dealing with that technical debt based on that definition within our organization. It's going to be an infrastructure example. I want to be very clear that the effort to deal with technical debt and figure out what it is for us and to eradicate it in our organization is by no means limited to infrastructure. I think it's all over the place. And I think as an engineering organization, Peach is doing an incredible job, and has done for the last couple of years, at dealing with this concept of technical debt. So there's this infrastructure tool called Terraform. If you haven't heard about it, don't worry too much. It's a way of defining your infrastructure as code. And one of the things that it has allowed us to do is capture a bunch of these decisions that we've spoken about and that we've agreed upon upfront. And what I mean by upfront is that it's allowed us to define in a piece of software some of these decisions and make them so that if someone else uses that software, they're going to get all of that good stuff kind of for free. They don't have to rethink about it for themselves. They don't have to re-implement it for themselves. And this notion of pre-baking in or front-loading the good behavior is a really, really useful strategy for actually tackling your technical debt. If you think about something and you decide it's a problem and you decide on a solution, then you want to think about how can we front load that so that throughout our organization, culturally, everyone gets to kind of do the right thing easily. The right thing must be the easiest thing to do. Otherwise, they're going to do something else. People are going to do whatever's the easiest thing to do, right? That's just human nature. No matter how good your intentions are, that's what you're going to end up doing. And so if you don't make the very good thing the easy thing to do, you're going to be constantly fighting that inertia. So this is don't worry about what the code actually means. I just want to point out a couple of things. One, this is a module, which means that it's reusable. It's a piece of code that can be reused over and over and over again, and that's a really useful concept. One of the great things about Terraform is that it provides a lot of reusability and a lot of composability. So you can take fairly simple chunks of code and you can compose them into quite complicated infrastructures. And that's a really useful thing. We're basically talking about building Lego blocks for other engineers to use. And it means that instead of coming to work and having to like build the Lego block themselves, they can take a bunch of pre-existing, you get like those really cool Lego shapes now, like the spaceship, like curves and the wings, and Lego just used to be like square and boring. Now it's rad. So we're trying to build rad Lego blocks for our engineers to use, and I think that's a really useful thing to do. Another thing is, you'll notice here at the bottom, we've got this thing called a Datadog space threshold. Don't worry too much about what that actually means. Other than the fact that we've baked into this piece of code a decision about what we're going to do about monitoring. We've had a conversation about what it means to monitor our infrastructure. We've had a conversation about what service we're going to use to monitor our infrastructure. We've had a conversation about at what point we're going to start being concerned about our infrastructure, like when things happen. And all of these decisions have been encapsulated in this line of code. And that's key, because it means that when another engineer comes along and uses this module to implement a workload runner, he doesn't have to think about that stuff again. He can just know that out of the box, he's going to get some kind of sensible behavior. Now, he can tweak it, or she can tweak it, they can tweak it. Say it a different way, Sven. Because they can change the values that are being implemented. Sorry, I just got stuck in a loop there. They can change the values, but the point is they can't undo the decision to implement some form of monitoring. And that's really key. So again, when it comes back to this idea of front-loading good decisions, this is the kind of effort. And what it means is that we don't have to keep having those conversations like, hey guys, what are we going to do about monitoring? Hey, what are we going to do about this? Hey, what are we going to do about that? It's like we're smart, motivated people. We're working in a very interesting industry, in a very interesting time. To be in financial services in Africa at this point in time in our lives is like a freaking gift, right? It's a very interesting space to be in. We don't want to have to be rethinking stuff like this. We want to be doing cool, interesting stuff, right? So, some final thoughts. One of the things you get when you tackle your technical debt is you get better security. And I know this is just one of a handful of things I could have pulled out, but it's really important. And again, in our industry, it's very, very important. But it really does improve the overall security of your organization and your software, because you're not going to be making trivial little mistakes, hopefully, because you're not thinking about trivial little things. You're thinking about the important things, and the trivial things have already been taken care of. It also means that you don't have a whole bunch of different ways of doing things that you have to consider uniquely every time you approach them. And so you can start to make sort of policy kinds of decisions. You can do kind of blanket thinking about something and say like, okay, well, this class of problem, it goes away for us because we're going to implement this particular solution and we're going to implement this particular pattern of doing things. It's like the Rust programming language got rid of a whole class of memory problems because they made a bunch of decisions about how they were going to implement the language and how the compiler was going to behave. Same thing for us. If we make sure that we've got monitoring, if we make sure that we have a bunch of rules in our infrastructure, in our cloud infrastructure, in our security posture, we don't have to worry about engineers occasionally slipping up on that stuff because it's already there for them. The other thing that you get, and I'm sure there'll be a couple of people from product who might disagree with me, which is why I put the asterisk, is you get to go to production faster. For some definition of faster. When you eradicate technical debt, that's kind of an ideal that's never going to happen. But when you start dealing with your technical debt, you become acutely aware of what's important and what's not important. And you become acutely aware of the things that you need to worry about and the things that you don't need to worry about, and the things that make a difference to your team and your customers and the things that don't. Because you're essentially looking at all of your dirty laundry. You're pulling out all the skeletons of your closet. You're saying like, right, we know we've got a bunch of problems in our infrastructure. We know we've got a bunch of problems in our code. Let's actually face it. Let's actually deal with it. And let's actually figure out like, what do we need to do to get rid of it, or at least make it smaller. And so when you're doing that, you end up kind of automatically going through this process of kind of cleansing. And that means getting rid of a bunch of stuff. I can't tell you how many times in the last year I've gone into some portion of our infrastructure and looked at a thing and gone like, oh, we actually don't need that anymore because we've handled this use case or this particular scenario in a totally different area of our code base in a totally different way. This whole thing can go. This whole repository can be deleted. This whole project can be archived. Like, we don't actually need to worry about it. And when you're not worrying about it and you're not thinking about it, you're not spending time maintaining it, you can focus your time and attention on other things. The other reason it gets you faster into production is because you're not having those same boring conversations about every little nuanced thing. The idea of software engineering in general is that we deal in abstractions. And when you build an abstraction, it's kind of like a platform for other people to stand on. And if you build a really good platform, you have people standing on it really, really solidly, and they don't need to worry about anything that goes on underneath. This is why we have this notion of platform engineering, right? Platform engineering is a thing in our industry. And so when you build up to a certain level in your organization from a cultural perspective, when you've made those decisions from a cultural perspective and you all have a standard way of talking about things and a standard way of thinking about things, and you have a bunch of agreements about a certain level that you're going to hold yourselves to, you don't need to go back. You can go forward from there. And it's like a leveling up. It's a step change in your ability to produce features and to deliver those features and to satisfy your customers' requirements. So I don't want to bore you anymore. I think I've given you a bunch of stuff to think about. Please feel free to come and fight me. I'm not like the be-all and end-all expert on things. These are some opinions based on my experience of working with teams, but I'm sure there are other people who've had different experiences, so please feel free to come and chat to me or anybody else if you've got some ideas or you've got questions. Thank you very much for your time and attention.